everyone, this is Miss Ann, and today, for those of you who might have missed our Fun Feats of Science class, I'm doing a quick little video to kind of go over what we talked about and what we learned during our Fun Feats of Science in February when we talked about dissolving and absorbing. When we started the class, we talked about the states of matter first. There are three states of matter. We have solid, liquid, and gas. So ask yourself, what is a solid? Do you guys know what a solid is? That's a good idea. Well, a solid is an object that can hold its shape and form. So if I had an object and I was to let it go, is it going to hold its shape? So let's talk about, maybe you have a cotton ball. If I let go of this cotton ball, is it going to hold its shape? Generally speaking, yeah. I can squish it, but it'll hold its shape. It's still there. This is a solid. The better example is if you have your watch is a solid, or if you have a block. When you put the block down and let go, it's going to hold its shape and it's going to hold its form. If left untouched, the material will not flow. Alright, so that's a solid. What about a liquid? I have a cup over here of water, and I'm going to pull it up in just a moment. Water is a liquid, but why is it a liquid? Ask yourself. Well, a liquid is a state in which the thing that's inside this cup cannot hold its shape. If I were to pour this out, it would go everywhere. We're not going to do that because I have books and things that I don't want to get wet. It actually takes the shape of the container. I put it in this container and it takes that shape. But it definitely has mass. You can see that this is where the water is. You can see that there's water there. So when it fills a container, it will fill it up from the bottom up. So gravity, bottom, up. And it has a definite mass. You can see it's there. You can see that it definitely is there. If I were to pour it out, it would be lighter. It has a mass. What about a gas? Can you think of anything in our lives that is a gas? You're right, air. Air is a gas. We have oxygen, we have carbon dioxide. These are all in the air, and these are gases. A gas will fill a container, but it actually spreads out throughout the whole container. It can't do from the bottom up like our liquid here, and often it's invisible. You won't see it unless it has a color to it. So those are the three states. We talk about that because we're going to be pouring things onto things, and we're going to use liquids and solids. Not as much gas, but liquids and solids for sure. So now we talk about dissolving and absorbing. If you have picked up a kit, that kit has most of the materials that you'll need to do the main experiment that we're going to be talking about. So at this time, you're going to get out your container that has a little bit of dye in it. It should be blue like that. So grab that and put that over your red plate. Anything else, just put off to the side. So you should have your red plate and your dye. What also you're going to need that is not included is a cup of water. So dissolving. What does it mean to dissolve? Well, I'll give you the nuts and bolts, the basic thing. Dissolve. A solid that becomes incorporated into a liquid. And so it becomes an entirely new solution. It becomes something entirely new. So, first we are going to, as we talked about our liquid, we're going to put our liquid into our cup full of the dye. What do you think is going to happen? First we're going to talk about what do you think is going to happen with our solution here. When I add this water, what do you think will happen to the water? Let's see if you're right. Did you guess that it would change color? Yeah, right? You knew that when you added water to the dye, it was going to change color. So you can use your little pipette and just mix everything together. Be careful when you open it, you might get a little dye on you. This dye that I've provided is just food-safe dye that you can add for food. So it should come out, shouldn't be a problem, but make sure you don't get it on your clothes. If you have a paper towel off to the side, that's a good idea. Okay, so dissolving is when you put a solid maybe in there, and then a liquid goes into it, and the solid will break up. But it's still in the solution. It becomes an entirely new solution, but it's still there. So right now, you're going to open your one little bag. I have 2 here of sugar cubes. And if you have water left in here, a sugar cube, if I were to add this to the water, what would happen? What do you think would happen? Well, let's find out. We're going to add our sugar cube, a solid. It has a definite mass. If I let it go, you can still see it looks like a cube. So this is a solid. I'm going to put this in the water. And you know what? I'm going to let this sit off to the side as we do the rest of our experiment, because I want to see what's going to happen at the very end and see how long it might take. So dissolving is a solid that becomes incorporated into a liquid. At the very end, we're going to talk about 3 other things. What is a solution, what is a solvent, and what is a solute. These are more advanced concepts, but we'll talk about that at the end. Alright, so that is the nuts and bolts of dissolving. But what about absorbing? Well, absorbing is the ability for something to soak up that water, to take that into itself. So a great example is to take a paper towel or a piece of paper. And let's see if you can see this. I'm going to just dunk it into the water and just give it a second. But you should start to see right there that the water is going up. This paper towel is soaking up and is climbing up the paper towel, even though the paper towel is going straight up. And see, even though the water was very shallow, it soaked up all the way up to here, and it's actually still moving. So being able to absorb is sucking up into itself. Now we're going to do a demonstration, and that's what this experiment is all about. So you're going to take your water that is now blue, and you're going to put it off to the side. And make sure that you don't get dye on your hands. And now you're going to use your sugar cubes. And we're going to test that theory out. First, you're going to take 3 sugar cubes. And you're going to make a stack on one side. You're going to take 3 more sugar cubes. And you're going to make a stack on the other side. So what we're going to test out is we're going to put the water on the bottom and see if we can see it go up. But then we're going to put it on the top and see if it goes down. And we're going to see how long it takes for something to rise up or come down. So let's start with the left-hand side, and we're going to put the water on the bottom. Do you think it's going to take? Do you think that that's going to take only a few seconds? Make a prediction. How long do you think it's going to take? And do you think that this is going to be slower or faster than the one that we're going to put on top? Make another prediction. So let's start. Take your pipette. That's what this is. And a pipette is really simple. You can also use a straw. So if you don't have this, you just plug the back of the straw and you'll have very similar to a pipette. The pipette is very simple. You put it in the water, you squeeze, and then you release while it's still in the water. And then you get a bunch of blue liquid. Now, if you don't have that, you could just pour a little tiny bit in a cup, like a Dixie cup, and then pour it. That's okay too. Whatever you have on hand. You will need a paper plate, a plate that is going to be either plastic or that's something that's not going to soak up water. You could use a paper plate, but it's going to have to be pretty thick. All right, here we go. Let's pour it on the side. So what are we seeing? Yeah, we're seeing that the blue liquid is rising up. I wonder how many of these we're going to need, so let's put some more. Do you think it's going to jump to the next one? We're starting to see, yes, and oh no, the structural integrity of everything, because this dissolves in water, it started to break up, and it fell. What do you think is going to happen with the one on the top? Do you think that's going to fall? Something we didn't think of. Alright, so now we're going to fill our pipette, and it did fill up to 2, but then it fell. So you can make a note of that if you were to write out what was going on. Let's try the top. You can do it slow or you can do it fast. So look, I put this whole thing on and the bottom one, it fell. But what about this one? It's not falling, so let's try some more. Let's see if we can get it to flow all the way through. And this is basically what the paper towel was showing you as well, the ability to absorb. Now, in the case of this is the demonstration because we know that sugar cubes are going to dissolve, they're going to break up, as we saw with the one on the left. Okay, let's put some more. But if you put enough, it will fill all the way to the bottom. Alright, so we did another experiment last week. So we're going to move all of this off to the side, and you're going to use the section that is not currently being used. You can do a bridge if you want with your sugar cubes, but somebody had an idea of, well, what would happen if you did it in a line? Let's do a line of 3. And if we only put it on one side, do you think it's going to cut across? Make a prediction now. Alright, let's test it out. First off, I put it off to the side, and then it soaks it up. And let's put some more. See, it soaks it up, and it's actually pulling it in. See if you can see. So yeah, let's try one more. You guys see what happens? I put it off to the side, and it's soaking it in, and it's cutting across. And now you're starting to see that it will cut all the way across. Good job. So, yeah, it'll soak it in. It's absorbing it really quickly, and then in this case, the sugar cubes is going to dissolve over time if we add so much water. But yeah, it's just like the paper towel. It's soaking it up, it's bringing all that moisture in, and it's cutting all the way across. Alright, so we're going to move that off to the side. And we're going to do one more. If you have a paper towel and you want to dab some of this out of the way, you can. You want it to be pretty dry when you do the next version of this experiment. There we go. So the last one we're going to do was an experiment that somebody had. What if you made it into a cube and you put the water in the middle? Do you think it would absorb? So we're going to try that. We're going to make a cube going around. So here's, you do 3, 3, 3. You should have just enough, because I gave you guys just enough of these. And if you didn't get one of these kits, that's okay. Sugar cubes are fairly inexpensive, however you can, instead of using sugar cubes, you can use the paper towels to do this experiment, which is afterwards. So what I did is, there's one cube missing from the center here. And so we're going to add the moisture to the center. And then you predict which one of these is it going to get. Is going to get blue. And you think that any of them are going to start breaking up. How many will it take? So and so. You know, try to ask a lot of questions. Alright, so let's take our moisture and our blue water. We're just going to put it in the middle. And if you can't see, I'll pull this up. Are we seeing anything? Yeah, we're starting to see the blue being absorbed over here. And you can just keep adding the blue liquid. And yeah, so it's eventually going to soak up all of this, and you can see how it's moving. Another thing that you can do, if you have a timer, you can time how long it takes to go through all of them. And that's like the absorption rate. And now it's starting to break up. So remember, off to the side, we had our cup of water with 1 sugar cube in it. Do you guys see that sugar cube? No, because it dissolved. It broke up. However, if you have sugar and you add it to a cup of water and you tasted it, what would it taste like? Is that sugar still there? A little bit, because it's going to taste sweet. The water before wouldn't have tasted sweet. Now, if you were to taste that water, it would be very sweet. If you pick up a kit, do not taste the water. This is only if you have sugar on hand and you would like to do it. Ask your parents, okay? Alright. So, the last thing that you can do is, if you picked up the kit, you were given a little sheet, you can go through and write substances in here and use your pipette and your blue water or whatever color water, and you can see if materials will absorb, soak in, or repel, where it's just going to sit. An example of repelling is if you have wax paper and you added water in droplets. You might be able to see this. you're seeing it's just staking on the bottom, and then I can pour it out. So that is repellent, where the water's just going to sit on top. It's not being soaked in. Alright, so you can go through your list here and see what materials will soak up water, what will repel water, what are good things at soaking up water. Can you think of any right now? Maybe a sponge. That's a good one. So you can go through this and keep the learning going. For those of you guys who want to learn a little bit more, I'm going to move my kit out of the way. There are 3 different things that we didn't talk about, but are great things to talk about when it comes to dissolving and absorbing. That is a solute, a solvent, and the solution. A solution is the end result of something that's been dissolved. So you have a solute and a solvent. And the end result, when you mix those two together, is our sugar water. It's now a new solution. The water before was not sweet, but if you were to taste it now it would be sweet. So it's a new solution. It's mixing. But what about solvent and solute? Well, a solvent is able to dissolve other substances. It's the water. It's this water that can dissolve things. So that is a solvent. A solute would be the sugar cube, the solid material that can be dissolved. So this is something that can be dissolved, so it's a solute. A solvent is the liquid that can dissolve something. So these are 2 things that we didn't really talk about, but it's a way to kind of keep that learning going. All right. So that is what we did in our Fun Feats of Science. Of course, this is a very abridged version. In our version, we did take some time. We asked questions. We talked to one another. So when you're doing these experiments, be sure to ask questions. Write down things that you think are going to happen before you do anything, and see if your predictions come true. Next month, we're going to be talking about fossils. Kits are available on October 1st on a first-come, first-served basis. So we're going to be talking about what creates fossils, what can be fossilized, and so we're going to be talking about that, and then we're going to play archaeologist by uncovering our own fossils. So we hope to see you guys next month for our Fun Feats of Science. Until then, we hope that you guys are doing well and stay safe out there, and we hope to see you very soon at our library.